2 Siennas in the class. Hi! Ones who are away, Chaska as well. So, can I ask, can we ask, if I said F, who, I'll have the roaming mic and try and disguise your voice a little bit. But we want to find the volume of this shape. The roaming mic. See if we can pick this mystery voice. How do we solve this volume question? Mystery voice, what would you do?
You find the volume of the sphere. Wait, is it the
But
volume
what
of the shape?
fraction of a sphere is it?
Oh, well, yeah, then you divide it by 2.
Love it. And the other shape?
You find the volume of the cone.
Correct. Now, last lesson, and you weren't here for this bit, and make sure that we have added it to our formula sheet, but my strong suggestion is for the cone, stop giggling, but the cone volume is 1/3 pi r squared times height. I think how it's written on the photocopied sheet is not very helpful. So, volume, is it?
No, it says area of base times by height.
Yeah, exactly. So, exactly, it's the same thing. And we also know that pyramids are 1/3 of the prism. So that's helpful. Yeah, I know you did. You're very good. So if I was doing this, just so the marker knows what's going on. Oh, Amy, if you were here, I'd be calling on your artistic ability here, because her diagrams are, oh my God. Actually, Bahija, yours are pretty good too. Nice artistic flair. So we would now go, this is 1/3 pi r squared times height. Now, mystery voice, that was you, mystery voice. You said the volume of a sphere. So again, this is not about memorizing. You are either looking at your own formula sheet now, or the formula sheet that you were given. You might have to look over there, my friend. Right? We want volume of a sphere. Who can tell me what's that formula? Jack, I go to you. Volume of a sphere. Sorry? So mystery voice is saying 4 times pi times radius squared. Rest of the class, what would we say to mystery voice? Why is it wrong? Because you've mixed it up. This is the surface area formula, right? So you've got to be really careful that you're reading your formulas correctly. All right? So it's 4/3 pi r cubed. And what do? We don't want the whole. We're going to cut it in half, so we will divide by 2. All that's left for you to work out is, do we know the radius of the cone? Yep, it's 5. Oops, put it over here. And do we know the height? Yes, it's 9. So we just slap it all in, and it becomes a calculator issue. Yeah? So can we take requests for the next 5 minutes? Take requests of anyone else that has a problem. So we're just taking a little bit of a request options from the class now. This was one of the first requests. We want to find the volume, and we'll rove around again. Who would like to say, how do we do it? Oh, mystery voice again. Or what about this mystery voice? Who can pick it? No. That might give it away.
Oh, am I supposed to do the volume of that? Well, it would be like 9. It's 900 times 1200 minus. Oh gosh. It's like lots of
You gotta get your theory going first. How do we get the volume of any funky shape? So do we agree if we have a funky shape like this, we want to find the area there, times it by the depth, correct? Yes? Can I come or no? I should just chuck it and you can. Yes, mystery voice number 2.
You should split the weird stair thing into rectangles. So it would be 900 times 300 and then 600 times 300.
Love it, love it. So we're going to break it up into shapes that we know. So we're not worried about the depth at the moment, right? We're going to go here. So we've got 1, and then we can go across here, and 2. And of course, you could have gone down if you really wanted to. Yeah? Anyone think of another way that they could do it? Yeah?
You find so if it's like a whole shape, but then you find like a whole rectangle, and you find the area of...
He's saying you find the area of what's missing. Yes, you could take what's missing and take it away. Absolutely. Yes, is. Should I throw you the mark or not? Right. Yes. Do we know it's exactly 1/3? How? Yes. So I was also thinking you can say, look, 1, 2, 3, 4, 5, 6. So you could just find one of these, times it by 6. So lots of ways that you could do it. You don't have to stick with one. However, think about that for your test. You are all going to be writing down what you're thinking in your head, hopefully, and it's going to be different things. Doesn't mean it's wrong, but I have to be able to follow it. So don't just put random numbers down. You sort of have to explain what's going on in your head so I can give you the maximum marks possible. I don't want to take marks off. I'm a giver. Give. So we'll stick with what we were talking about originally, but I love the thought process that people were going through. My last bit is, how do I know this length here? Rubes, how did you get this length? It's 900. Split into 3. That's right. So we know that that would be 900 divided by 3. So that's 300. Okay. So I think I'm just going to go one of these and I'm going to times it by 1, 2, 3, 4, 5, 6. That's just easier. So it'll be 300 times 300, which gives you the area of that. Get the volume by timesing it by the depth, and because there's 6 of them, times it by 6. All right. If you're playing at home, question 4 was the next one. So we've got a circular cake tin, has a radius of 20 centimetres. I did. So here we go. Ooh. Thank you very much. All right. It has a radius of 20 centimetres. Rock the colour. 20, and it has a height of 7. When cake mix was added to the tin, its depth was 2 centimetres. So we've got, anybody watch Mary Berry on a Sunday night, 7:30? I love that. She makes good cakes. So that height there was 2 centimetres. What's going to happen to the cake? We hope, unlike some of my cooking. Anyway. Oh, sketch the 2 situations. Okay, that's the second situation. And that was the first one. Oh, let's go colour coding. There's the empty tin. All right. Oh, I need to finish reading the question. Thanks, kids. The second one, after the cake was cooked, it rose to 1.5 metres below the top of the tin. Ooh. That's pretty good. So we've got 20. Loco, you got this. If it was 7, but it came down here by 1.5, how high has the cake risen? 5.5. Thank you from the crowd. You can almost smell it. All right. Sketch the 2 situations. Done. Find the volume of the cake mix. We agree this would be the mix. All right, so how do we get the volume of the mix? It's still a cylinder, would you agree? So pi r squared times height. What is my radius? 20. That's not changing. What is my height? Now, this becomes, I think, a pretty easy question if you have drawn diagrams and labelled them clearly. Right? It then becomes pi times 20 squared times 2. Pop that in. And I'll give you a moment for you to find the volume of the cooked cake. Yep, so you'll get your volume here. People were just sussing, what about D? I love that they put this, the increase. Basically, we say that that is also the change. So have a look at the volume that you got. So V minus the other volume. And you want to divide by the original. So what was the original volume? Green or? Green. It was green. So, and times by 100. Now, obviously, what do you expect when you go the green, take away the orange? You're going to get a negative value, aren't you? Right? Just ignore that. Ignore that. You'll be all right. Ignore the negative. Because it's gone from here to here, so it would be like a 100% increase or something. It should be a big increase because it's going to almost, it's more than doubled in volume, yeah?